Hello guys, are you ready for our next lesson? Okay, I want you to show something and of course consider and observe it closely. Okay, take a look on the figure. What do you observe? That's right. This is now an orbit of the Earth taken around the Sun. And likewise with the other planets. And it is said to be in elliptical in shape. Okay, this is just a real life example of an ellipse. And of course, we're going to tackle it today. Now, what are our learning competencies? The first one is we're going to define an ellipse. Second, to write the standard form and the general form of the equation of an ellipse. And of course, the third one is we're going to graph an ellipse in a rectangular coordinate system. Okay, now let's define. What is an ellipse? Ellipse here is said to be set of all points in P in a plane such that the sum of these distances of this P from 2 points, okay, namely we have the F prime and F, as what on the diagram there, and of course this plane is said to be constant. This constant sum is equal to the length of your major axis, which is denoted by 2a. Each of these fixed points now is called your foci, the plural form for focus. And in our diagram, it is denoted by F prime and F. Okay, let's take a look on the other properties of an ellipse. Okay, so there you have. The curve of an ellipse intersects the major axis at 2 points. Okay, what are these 2 points? We have now your two vertex or vertices. Okay, and usually it is denoted by V or V prime and of course V sub 1 or V sub 2. The major axis is denoted by 2a, where your a is said to be the distance from the center to your vertex. Okay, and of course it contains also the coordinates of your foci or your focus, and your foci is denoted by F sub 1 or F1, okay, and then F2. Okay, after that, this foci is denoted by C, where it is said to be the distance from the center to your focus. Okay, so a while ago, A from the center to your vertex. This time, C stands for the center, distance from the center to your focus. Okay, and the midpoint of your major axis is called now your center of the ellipse, and of course denoted by capital C. On the other hand, your minor axis is denoted by 2b. Okay, this b now is stands for the distance from the center to your co-vertex, or simply some other textbooks it is said to be the ends of minor axis or M. Okay, the lines through your focus, okay, your F sub 1 and F sub 2, okay, is perpendicular to the major axis, are called now your lateral recta, and each has a length of 2b square. And to make it symmetric, okay, we have to divide it into 2, and to locate your ends of your lateral recta or ELR starts from the focus. So again, your LR, which is the formula 2b squared over a, is to be divided into 2 to make what? Symmetric on your ALR, starting from the focus. Okay, the distance from the center to your directrix, okay, is represented or denoted by D. So again, from the center to your directrix. And of course, the last property we have here to define is the eccentricity. It is said to be referring to the measure of the degree of flatness of an ellipse. Okay, flatness of an ellipse. And it is called now the ratio of the distance of each point on the curve from a given focal point to the distance from the same point on the curve to the directrix is constant. And we have the formula for eccentricity, which is your C over A. And take note, your eccentricity of an ellipse is said to be less than 1. Okay? Now, let's proceed with our equations of our ellipse. Now, we have two forms of our equation, namely, we have the standard form. And under the standard form, we are going to tackle first the center at origin. Okay? Now, if it's centered at origin, we take a look here with the formula. We have x squared over a squared plus y squared over b squared equals 1. And what does a squared denotes again? It denotes your major axis. That's why if you take a look on our diagram, okay, our graph of your center at origin, which is said to be major at x-axis. So it is said to be horizontal. Okay, and your b square here is said to be the minor axis. On the other hand, okay, you notice here that our major axis is said to be on the y-axis or along y-axis. That's why a square is under y square. Okay, and take note, our standard form is said to be equated to 1. So again, types of your ellipse, it's either vertical because major axis is along the y-axis, and of course horizontal, your major axis is along your x-axis. Let's proceed with the second type of the standard form, which is center at HK. The same concept on what we have discussed on center at origin. Okay, with respect to your major axis, your a square is under x, or simply it is parallel to x-axis. That's why it's again horizontal. On the other hand, okay, your major axis here is parallel to y-axis. As you observe, your a square is under your variable y. So again, horizontal and vertical ellipse. Okay, after the standard form, let's proceed now with what? The general form. Our general form states here that both your variable x and y appears on the second degree. And take note, they have the same sign, they're both positive, but they have different numerical coefficients. As it denotes here on our form, ax squared plus by squared plus cx plus dy plus e equals 0. Again, take note, general form, it is always be equated to 0. A while ago in the standard form, it is equated to 1. Okay? Now, let's take a rule for converting standard form to general form. We have here a standard form, quantity x minus 3 square over 16 plus quantity y minus 3 square over 9 equals 1. Okay, so how do you convert this to general form? Okay, there you have our steps. We simply cross-multiply the denominators. As you notice, 9 here on your variable y to be what? Cross-multiply here. That's why you have there. And then, of course, 16 on your variable y, variable x is to be cross-multiply here. That's why you have 16, quantity y minus 3. And, of course, under your constant, we simply multiply your denominators, 16 times 9. There you have. So, again, the first step, we cross-multiply our denominators. Afterwards, we expand our binomials. There you have. Simply expand this binomial. And then, of course, we expand also your second binomial with respect to y. There you have. And, of course, simplify your constant. 16 times 9 is simply 144. Okay? Then, of course, we have still factors here. So, we need to distribute. Okay? So, there you have. 9x squared minus 36x plus 36 because we have distributed a distributive property of an equation. So we will distribute 9 and then on the other hand, distribute 16 here. That's why we have 16y squared minus 96y plus 144 because we have distributed. Okay, and of course, we all know that in general form, it is always equated to 0. So our constant here is to be written on the other side, transpose, and it becomes negative 144, then equate to 0. Afterwards, arrange it from our general form. So we have 9x squared plus 16y squared minus 36x. Okay, then minus 96y. Then of course, we are going to simplify by combining like terms with respect to your constants. 36 plus 144 minus 144, so this is cancelled. Automatic, we have positive 36 equals 0. So there you have our converting of standard form to general form. We cross-multiply our denominators, okay, expand the binomials, distribute the other factors, and of course, we simply arrange the terms in the general form combining your constant terms and equate to 0. Now, we're going to convert general form to your standard form with this example. 25x squared plus 16y squared minus 150x minus 128y plus 81 equals 0. So how do we do? Converting from JF to SF, we simply, the first step is to group like terms. Meaning, with respect to x, we group them. So 25x squared and 150x. There you have. The same true with y. We group also 16y squared and negative 128y. And, of course, our constant is to be written on the other side. That's the very first step. Okay, we are to group the terms with respect to the variable and the constant on the other side. The next thing to consider here is to extract your numerical coefficients on the second degree. So with respect to x, we extract 25. With respect to y squared, we extract 16. So, there you have. We have extracted 25. So, 25 or 150 over 25 is simply negative 6. The same to here, negative 128 over 16 is simply negative 8. So, again, we extract the numerical coefficients of your variable on the second degree. Okay. And, of course, after that, the next thing to consider is we apply computing the square method. Okay, that's why we have blanks. Okay, you know already how to apply computing the square. So we have negative 6 over 2 square it. So we have 9. So we have to write 9 here. Okay, and of course this time, the only difference with what we apply for completing the square, this time we need to multiply this 9 to our external factor, which is 25. So 25 times 9, we're going to write here 225. Okay? Bear in mind with that. That is the common error of students. When they apply completing this square, they simply copy 9 or write 9 here and then they write here 9 also. But note, we have here a factor which is 25. So the same true with respect to y. Negative 8 over 2, then square it, it's 16. So we're going to write 16 here. Okay, and this time 16 times 16, it's 256. So there you have. So because we are already a perfect square trinomial, factor this out. X squared minus 6x plus 9, and that is quantity x minus 3 squared. The same true with y squared minus 8y plus 16. It's a perfect square trinomial, so we have quantity y minus 4 squared. Okay, then simplify constants. Negative 81 plus 225 plus 256, it's 400. Okay, after doing that, okay, we remember that our standard form should be equated to 1. So how will you make your constant here equals to 1? Yes, you're right. We're going to divide both sides with 400. So divide both sides with 400. And what will you do with this? We simply get the lowest term, 25 over 400. And that is 1 over 16, or simply x minus 3 quantity square over 16. The same true here, 16 over 400, get the lowest term. Yes, it's 1 over 25. So that's why we have quantity y minus 4 square over 25. And of course, 400 over 400 is equals to 1. So there you have our from general form to standard form. And this is now our final answer. Again, recall, we're going to group the terms with respect to your variable. And of course, constant is to be written on the other side. Okay, and of course, extract the numerical coefficients of your variable on the second degree and apply completing the square. Of course, take note of the factor. You're going to multiply the factor on the other side. Okay, and apply factor out your perfect square trinomial. And of course, your standard form should always be equated to 1. So divide both sides with respect to your constant and get the lowest term. And of course, the denominator now is equated to, or of course, the standard form is equated to 1. Okay, this is now our final answer. So again, we are through with the definition, we are through with our standard form and then the general form. Last competency is we are going to graph an ellipse. Okay, how do we graph an ellipse? Of course, we identify first our major axis. So with respect to this one, our major axis is said to be on your x-axis, because 25 and 9, considering 25 is under x, and of course your minor axis is with respect to your y. And of course, as you take a look on our standard form, it is said to be what? Centered at origin. Okay, there you have. So again, our major axis is a squared equals 25. Then extract it. We have positive or negative 5. And again, take note, our a stands for the distance from your center to your vertex. Let's show it on the graph. Okay, so this is now our center from the origin. Then 5 units to the right. 1, 2, 3, 4, 5. Okay, there you have. Then 1, 2, 3, 4, 5 on the other side. There you have our vertex 1 and vertex 2, or simply V1 and V2. Okay, let's proceed. This time, after the major axis, to show our minor axis, which is 9, and extract it, we have B, therefore is positive or negative 3. And take note, this is the distance from your center to your ends of minor axis. So again, show it on the graph. We have the from the center, 3 units upward, 1, 2, 3. Okay, there you have. And 1, 2, 3, there you have our ends of minor axis, or your co-vertex. Afterwards, okay, we are now ready to identify our c square. From the formula a square minus b square, we simply substitute. We have 25 minus 9 equals 16. Then extract it also. Take note that your c should always refer to our distance from the center to your focus, and that is 4. So again, show it on the graph. So from the center, 4 units to the right. Okay, there you have. 4 units to the left. Okay, there you have. So we have already your vertices, we have already our foci, we have already our co-vertices, or simply your ends of minor axis. Let's continue. Our LR this time with the formula 2b squared over a. So it's just a matter of substitution. So our b squared is 9. So 2 times 9, then our a is 5. So 2 times 9 over 5, then it's equals to 3.6. Our LR is said to be 3.6. To make it symmetric, divide it into 2. That's why we have 1.8. Take note, our LR is what? The distance now from your focus, starting from your focus to your ends of latus rectum, or lateral recta. Let's show it on the graph. Okay, so again, from the focus, 1.8. So 1.8, there you have. And then another thing, downward, 1.8, there you have. And with respect to its coordinates, the same through here again. Okay, 1.8. Okay, there you have. Then 1.8, there you have. Okay, so what do you observe? We have now complete our graph with respect to your vertex, with respect to your focus, with respect to your minor axis, and your ELR. We are now ready to connect. So we are ready to connect. There you have. Once we connect, take note, we are not to connect your focus and your center, but instead all those outside points. So there you have our graph. A while ago, we have identified that it is said to be an horizontal ellipse. Okay, we are not done yet. We need to solve first for your eccentricity. Okay, our formula for eccentricity is c over a. Our value for c is simply, we have 4, and then of course our a is 5. And take note of our eccentricity of an ellipse, it should always be less than 1. So 4 over 5 or 0.8, that's correct. And of course, our relationship with respect to d, our distance from the center to your directrix. So our formula, a over e, which is 5 over 0.8, or simply it's 6.25. 6.25 from the center to your directrix. So again, let's graph it. 6.25 from the center. So 1, 2, 3, 4, 5, 6.25, which is okay with respect to x. 1, 2, 3, 4, 5, 6.25. Okay. So there you have our two directrices. And therefore, this is the complete details of our graph. Okay, take note again of what we have done. Of course, we consider the major axis, the minor axis, okay, your LR, and of course, our these different distances from A, B, C, D, and E. Okay, let's try another example. Okay, with this example, x minus 3 quantity square over 16 plus quantity y plus 4 square over 25 equals 1. Now, what do you observe? Yes, it is now centered at HK. Another thing to observe with respect to your major axis, with respect to y, so simply our type of ellipse is a vertical because our major axis is on your parallel to your y-axis. So again, what's our center? Yes, that's right. It's 3, negative 4. And our major axis is 25, which is 5 units from the center to your vertex. Let's show it in the graph. Okay, so our center, we have 3 units and then 4 units downward. And there you have. From the center, what? We're going to work, is it right or left, upward or downward? Take note, our type of ellipse is a vertical. So therefore, okay, 5 units upward. So we have 1, 2, 3, 4, 5. There you have our vertex. Then another 5 units downward. 1, 2, 3, 4, 5. There you have another vertex. So again, take note of our coordinates. Okay, starting from the center. Okay, there you have. Let's continue. After considering our major axis and your A, let's proceed with the minor axis, which is 16. There you have. Extract it. Our B now is positive or negative 4 from the center to your co-vertex or your M. Okay, let's show it. So again, 4 units. 1, 2, 3, 4. Okay, this is now our ends of minor axis 1. And of course, 4 units, 2, 3, 4. Okay, there you have another ends of minor axis. Okay, so after considering our ends of minor axis, or simply your b square and b, we are now ready to solve for c square. We have the formula a square minus b square. Substitute 25 minus 16, okay, equals 9. Then extract it. So simply we have positive or negative 3. Take note, our c stands for the distance from the center to your focus. Okay, so let's proceed again. From the center, 3 units to the right, 2, 3. Because our value of our c is, our major axis is on the vertical. So upward, 1, 2, 3. There you have. Then another 3 units downward. Okay, so there you have our coordinates of our F1 and F sub 2. Okay, from the center, 3 units upward, 3 units downward. Okay, let's proceed. Okay, your LR. LR from the formula 2b squared over a, and this time 2 times 16 over 5. Okay, 32 over 5 is 6.4. Again, to make it symmetric, 6.4 is 3.2 again from the focus to your ELR. From the focus to ELR. So 3.2. So we start here from our focus, 3.2. We have 1, 2, 3.2. Okay, there you have. That's your ELR1, which is negative 0.2, negative 1. Let's proceed on the other side. 1, 2, 3.2. Okay, so we have the coordinates 6.2 and of course negative 1. Next, from here 1, 2, 3.2. So there you have another ELR. Then from the focus 1, 2, 3.2, another ELR, which is negative 0.2 and negative 7. So take note of our coordinates. Okay, considering of course from the center. Now that we are through with our external points, we could now connect the dots and let's see what will be our ellipse. Yes, there you have it. Our ellipse is said to be a vertical. Okay, we're not through yet. Okay, we're to solve for our eccentricity. And our eccentricity is c over a, which is 3/5. Okay, it's just a matter of substitution from your C, value of your C, and value of your A, which is 0.6, and it's said to be less than 1. And of course, your D, your distance from the center to your directrix, is 5 over 0.6, and that is positive or negative 8.33 from your center to your directrix. So again, 8.33 from the center, 8.33 upward units. Okay, there you have, which is 4.33. The same through here, downward, 8.33 units. Okay, and we have y is equals to negative 12.33. This is now the complete details of our graph of our ellipse. Okay, now let's sum up our discussion on what we have today. We have discussed the definition of an ellipse. Okay, we have also discussed the equation of an ellipse from our standard form, centered at origin, centered at HK, and of course we have noticed that it is always equated to 1, considering your A square is the major axis, considering your B square as our minor axis, and of course our general form, which is always equated to 0. And lastly, we have discussed our procedure or our steps in graphing an ellipse. We simply start analyzing what type of ellipse is that. It's either vertical or horizontal, considering our center, considering our major, our minor, our LR, and then of course our values of our A, B, C, D, and E. Okay, so there you have, guys. So again, um, thank you for listening. And always remember guys, that handang isip, handa bukas. Tara na, ML na tayo. Okay? And of course, hoping that you have learned something today. And see you again on the next discussion. Okay? God bless guys.